All right, so here we are. We are finally learning trig identities. Trig identities are going to be really fun, and they go over some things we already know, which is nice. So we already know that tangent is equal to sine over cos. And some people get concerned about why the x is just representing a variable that could represent an angle measure. So you could easily just say tan equals sine over cos. So sometimes you'll see it with the x, sometimes you'll see it with a theta, but it's all the same thing. Cotan, we know, is 1 over tan, also known as cos over sine. Secant, we know, is 1 over cos, and cosecant is 1 over sine. So what we're going to do is sometimes simplify and sometimes verify. So the simplify is going to just take you back. Okay, when I see something in front of parentheses, I remember that I distribute that, right? And a lot of times what I'll do is drop out the x. So when I distribute it, I just might say something like tan times cos minus tan times cosecant. And then I'm going to reduce tan or replace it with its definition, which is sine over cos. And again, sine over cos. And cosecant is 1 over sine. And this is really cos over 1, right? And we remember when we multiply fractions here, if we've got the same thing on the top and bottom, that can cancel, and we have sine. And then here, the sines can similarly cancel, and I have 1 over cos, which is secant. And sometimes I throw the x's back in at the end, sometimes not. Maybe I will. Sine x, secant x. That's it. The next one, your math instinct will probably tell you to FOIL, right? Or double distribute. When I multiply sine times sine, I get sine squared x. I'll keep it in. Outers are going to be plus sine times cos, and then the inners are going to be minus cos times sine. And I didn't write the x on purpose because I'm going to notice that these two are essentially just going to cancel out, right? And then I have minus cos squared. So sine cos and cosine, those are opposites of each other, so those drop out, and then this simplifies to sine squared minus cosine squared. Now we see our variable, not an x, but a theta. This is a variable we use in trig a lot. I'm going to drop it out, though, for a second. Tan is sine over cos. Cosecant's 1 over sine. And then secant, of course, is 1 over cos. There, the sines can cancel. I get 1 over cos over 1 over cos, which I could tell right away that that's 1, but some people like to actually say, isn't that secant over secant? Yes, and isn't that just something over itself? So 1. Yep. So those are some examples of simplifying trig expressions, just going back to our definitions, replacing words like tan with sine over cos, etc., and then simplifying like we already know. And this is the main thing we're going to learn today, this Pythagorean identity. Sine squared plus cosine squared equals 1. This is a biggie. We've actually subtly introduced it to you long ago. So you might remember the unit circle, right? Do you remember what the radius of the unit circle is? You're right, radius is 1. Do you remember what the x and y stand for in relation to the angle? You are right, the x is the cosine of the angle, the y is the sine of the angle. So if I go back to my right triangle, the x here, if the hypotenuse is 1, is the cosine, and the y here, if the hypotenuse is 1, is the sine. And then what theorem does that shape remind you of? You are right, it reminds you of the Pythagorean theorem. So it's going to be cosine squared plus sine squared equals 1 squared. Cos squared plus sine squared equals 1 squared. And I think you can agree that we can just change the order to say sine squared plus cosine squared, and of course 1 squared is just 1. And like I said, sometimes I'll write it with the x representing the angle, and sometimes we drop it out. It's just understood that you would be taking that of an angle. So that's like a big deal, sine squared plus cosine squared equals 1. And it has two what we call spin-offs. How I'm doing the spin-offs is I'm taking either cosine squared and subtracting it from both sides. So sine squared equals 1 minus cosine squared, just kind of moving that over. Or I'm just taking the same original thing and subtracting sine squared from both sides. Minus sine squared, taking that and moving it over. And that gives me this version. Oh, so here I have you write it out. So to show the spin-off, I'm just going to subtract cosine squared from both sides. So therefore, sine squared, I'll add in the x, is equal to 1 minus cosine squared. And I just call that a spin-off. The next one here, same thing. To show this spin-off, I'm just going to subtract sine squared from both sides. So cos squared equals 1 minus sine squared. And again, with or without the x. One with, one without. There's two more versions of this Pythagorean identity, and they look different. 1 plus cotan squared equals cosecant squared. Tan squared plus 1 equals secant squared. But we're going to show that those are just different versions of the main Pythagorean identity. Sine squared plus cosine squared equals 1. How we're going to prove those identities is take the main Pythagorean identity and divide everything by sine squared. You remember from Algebra 1, we are allowed to divide both sides or divide every term in an equation by something as long as it's not 0. Sine squared over sine squared, wasn't that just 1? What's cos squared over sine squared? You're right. Cotan squared. What's 1 over sine squared? You're right, cosecant squared. Ta-da! 1 plus cotangent squared equals cosecant squared. All we did was take the main trig identity and divide everything by sine squared. Now here, similarly, we're going to take the main trig identity. You can probably see where this is going. Divide everything by cos squared. Sine squared over cos squared is tan squared. Cos squared over cos squared is 1. And 1 over cos squared is secant squared. And there's our last version of Pythagorean identities. Each of these Pythagorean identities have their own spin-offs. That's like kind of the last thing. Like it's an easy one where you just would subtract 1 from both sides. And so another version of this is cotan squared equals cosecant squared minus 1. And another version of this one is tan squared equals secant squared minus 1. So there's two ways to look at it. One way is like, oh my gosh, there's all these formulas, right? But another way is like, well, these formulas we already knew. This formula is new, but it makes total sense. And every other formula is just a version of the main formula, either by subtracting from both sides, or dividing everything by sine squared or by cos squared, or then taking those versions and moving the one to the other side. So that is your intro to trig identities.